Welcome back. We want to continue unveiling facts about our remaining planet. Let's discuss about Jupiter. Jupiter, the largest planet in our solar system, was discovered and observed by ancient astronomers, and its detailed study began with the invention of telescopes. With a radius of 43,440.7 miles, 69,911 kilometers, Jupiter is 11 times wider than Earth. If Earth were the size of a nickel, Jupiter would be about as big as a basketball. It is one of the brightest objects in the night sky and is identifiable by its iconic Great Red Spot, a giant storm larger than Earth. Jupiter's hidden nature is evidenced by its dynamic atmosphere, consisting primarily of hydrogen and helium, and its extensive system of colorful clouds and turbulent storms, including the aforementioned Great Red Spot, too. While no complex life forms are believed to exist on Jupiter due to its inhospitable gaseous environment, scientific exploration continues to seek evidence of possible unknown phenomena or microscopic life within its atmosphere and on its moons. Jupiter's thick atmosphere consists of bands of clouds, powerful winds, and a distinct lack of solid surface. Its average distance from the Sun is approximately 484 million miles, 778 million kilometers, placing it 5.2 astronomical units away. 1. The planet's extreme size and mass contribute to its strong gravitational pull, making it the focal point of a diverse system of moons and rings. The knowledge about Jupiter has been contributed by numerous individuals and organizations, including those involved in space missions, such as the ongoing missions by NASA. They have provided invaluable data on Jupiter's atmospheric composition, weather patterns, and the unique characteristics of its moons. Jupiter holds a prominent place in our solar system, with its discovery, unique characteristics, and the ongoing exploration contributing to our understanding of the complex nature of gas giant planets. Let's talk about Saturn. Saturn has been known since ancient times. It is one of the 5 planets visible to the naked eye. It was recognized by ancient civilizations, including the Babylonians, around 700 BC. The planet was named after the Roman god of agriculture. However, the first telescopic observations were made by Galileo Galilei in 1610, who observed its rings but couldn't clearly discern their structure. In 1610, Galileo was the first to document Saturn through a telescope. He noticed the rings but described them as ears due to his limited view. Christian Huygens in 1655 discovered Saturn's largest moon, Titan, and proposed that the rings were a disk surrounding the planet. In 1675, Jean-Dominique Cassini observed the division in the rings, known as the Cassini division, and discovered several of Saturn's moons, including Iapetus and Rhea. Voyager missions, 1979-1980. NASA's Voyager 1 and Voyager 2 provided unprecedented detailed images of Saturn and its rings, revealing their complex structure and dynamics. Cassini-Huygens mission, 2004-2017. This mission provided in-depth information about Saturn, its rings, and its moons. The Huygens probe landed on Titan in 2005, revealing its thick atmosphere and liquid methane lakes. Galileo Galilei, the first to observe Saturn with a telescope, identified Titan and made significant contributions to understanding Saturn's rings. Made detailed observations of the rings and discovered multiple moons. Saturn is primarily composed of hydrogen and helium, with trace amounts of other gases. It lacks a solid surface, being a gas giant. Saturn's rings are the most extensive and brightest in the solar system, made primarily of ice particles, with some rocky debris and dust. Saturn has over 60 known moons. Titan, the largest, is larger than the planet Mercury and has a thick atmosphere rich in nitrogen. Saturn experiences the fastest winds in the solar system, reaching up to 1,100 miles per hour, 1,800 kilometers per hour. A day on Saturn lasts about 10.7 hours, but its year is equivalent to about 29.5 Earth years. Saturn remains one of the most studied and intriguing planets in our solar system, captivating scientists and astronomy enthusiasts alike with its beauty and complexity. Uranus. Uranus was discovered on March 13, 1781. The planet was discovered by astronomer William Herschel, who initially thought it was a comet. Uranus holds the distinction of being the first planet identified with a telescope, marking a significant advancement in astronomy. Uranus is classified as an ice giant, primarily composed of water, ammonia, and methane ices, with a hydrogen and helium atmosphere. The planet's striking blue color is due to the absorption of red light by methane in its atmosphere. Uranus has one of the coldest atmospheres in the solar system, with minimum temperatures dropping to around -370 degrees Fahrenheit, -224 degrees Celsius. Uranus has a faint ring system composed of narrow, dark rings that are difficult to see, adding to its uniqueness. Uranus has 27 known moons, with Titania, Oberon, Miranda, Ariel, and Umbriel being the largest and most studied. Upon discovering Uranus, Herschel observed its disk and movement, distinguishing it from the stars. He initially named it Georgium Sidus, George's star, in honor of King George III, but the name Uranus was later adopted. Herschel also discovered two of Uranus's moons, Titania and Oberon, in 1787. Scientists later discovered Uranus's peculiar axial tilt of about 98 degrees, resulting in extreme seasonal variations and causing its poles to point nearly directly at the Sun during parts of its orbit. NASA's Voyager 2 remains the only spacecraft to have visited Uranus, providing invaluable data about its atmosphere, rings, and moons, revealing details about its complex weather patterns. William Herschel, the discoverer of Uranus and its first two moons. John Couch Adams and Urbain Le Verrier. These mathematicians predicted the existence of Neptune, indirectly leading to further studies of Uranus's gravitational influences. Jacques Amdl van de Hulst also contributed to the understanding of Uranus's atmospheric composition through radio observations. The Voyager 2 team was launched on August 20, 1977, as part of NASA's Voyager program, designed for long-term planetary exploration. The primary goals included studying the outer planets, their moons, rings, and magnetic fields. Voyager 2 would eventually fly by Uranus and Neptune, gathering data to enhance our understanding of these distant worlds. Voyager 2 made its closest approach to Uranus on January 24, 1986, and provided the first detailed images and scientific data about the planet and its system. The spacecraft sent back over 10,000 images and a wealth of data, enabling scientists to study Uranus in unprecedented detail. Before Voyager 2, only faint hints of Uranus's rings were known. The flyby revealed a complex ring system made up of narrow, dark rings composed primarily of ice particles and dust. The rings were found to be less prominent than those of Saturn, but Voyager's data indicated that they contain particles ranging in size from microscopic to boulder size. Observations revealed that the rings have sharp edges, suggesting the presence of shepherd moons that help maintain their structure by gravitationally confining the ring material. Voyager 2 provided detailed images of several of Uranus's largest moons, including Titania, Oberon, Ariel, Miranda, and Umbriel. The mission uncovered diverse geological features on these moons, such as Miranda showcased an unusual and varied landscape with canyons, cliffs, and a mix of old and young terrain, suggesting a complex geological history. Ariel exhibited a heavily cratered surface with bright regions, indicating past geological activity, possibly including cryovolcanism. Titania and Oberon revealed large canyons and impact craters, hinting at their icy composition and potential geological evolution. Voyager 2 measured Uranus's atmosphere, providing data on its composition, temperature, and weather patterns. It found the atmosphere to be primarily hydrogen and helium, with trace amounts of methane influencing its blue color. The mission also studied Uranus's unusual magnetic field, which is tilted at 59 degrees from its rotational axis and offset from the planet's center. This finding led to questions about the planet's internal structure and dynamics. The findings continue to inform studies of ice giants in our solar system and exoplanets beyond, contributing to a broader understanding of planetary formation and evolution. The Voyager 2 mission remains one of the most significant achievements in space exploration, with its contributions to our knowledge of Uranus marking a pivotal moment in the field of planetary science. Neptune. Neptune was discovered on September 23, 1846. The planet was independently discovered by Johann Galle and Heinrich de Rest based on calculations made by Urbain Le Verrier and John Couch Adams. Their theoretical predictions of Neptune's position led to the successful observation of the planet. Before its discovery, astronomers noticed irregularities in Uranus's orbit that could not be explained by Newtonian physics. This led Leverrier and Adams to predict the existence of another planet beyond Uranus. Their calculations pinpointed Neptune's location in the sky. Gale and de Rest confirmed the discovery by observing Neptune in Berlin. Gale famously found Neptune just 1 degree away from the predicted location. Initial observations revealed a striking blue color, attributed to methane in its atmosphere, which absorbs red light. Urbain Leverrier, a French mathematician whose calculations led to the discovery of Neptune. John Couch Adams, an English mathematician who independently calculated the position of Neptune, working simultaneously with Leverrier. Johann Gale is the astronomer who first observed Neptune, confirming its existence based on Leverrier's predictions. Voyager 2 Team, 1989. The team behind the Voyager 2 mission, which provided the first detailed images and scientific data about Neptune during its flyby. The spacecraft revealed that Neptune has some of the fastest winds in the solar system, reaching speeds of up to 1,500 miles per hour, 2,400 kilometers per hour, creating stunning storms in its atmosphere. Voyager 2 discovered a massive storm, dubbed the Great Dark Spot, similar to Jupiter's Great Red Spot. This storm was later found to be a temporary phenomenon. The mission identified several of Neptune's moons, including Triton, which is unique for its retrograde orbit, orbiting in the opposite direction of Neptune's rotation. Voyager 2 also found Neptune has a faint ring system composed of ice and dust particles. Neptune is the coldest planet in our solar system, with temperatures dropping as low as -414 degrees Fahrenheit, -248 degrees Celsius. Neptune's atmosphere is composed primarily of hydrogen, helium, and methane, which gives it its distinctive blue hue. Neptune is the 8th and farthest planet from the Sun, about 30 times farther than Earth, with a diameter of approximately 30,598 miles, 49,244 kilometers. Neptune experiences extreme seasonal changes, with each season lasting around 40 Earth years due to its long orbital period of about 165 Earth years. Neptune remains one of the most enigmatic planets in our solar system, captivating scientists and astronomy enthusiasts with its unique features and mysteries. Pluto, the dwarf planet. Pluto, once considered the 9th planet in our solar system, was first discovered on February 18, 1930, by astronomer Clyde Tombaugh at the Lowell Observatory in Flagstaff, Arizona. Tombaugh's meticulous observations led to the identification of Pluto as a distant celestial body beyond Neptune. Its discovery marked a significant milestone in the exploration of our solar system, adding a new member to the planetary family. Recent observations have revealed mysterious dark spots on the surface of Pluto, whose origin and composition remain unclear to scientists. These spots have puzzled researchers and sparked further investigation into the geology of this distant dwarf planet. Pluto's atmosphere contains methane, and scientists have observed unexplained fluctuations in methane levels over time. The reasons behind these variations, whether due to seasonal changes or other factors, are still not fully understood and continue to be a subject of research. There is speculation among astronomers that Pluto may harbor a subsurface ocean beneath its icy crust. The presence of such an ocean could have significant implications for the planet's geology, potential habitability, and overall dynamics, adding to the mystery surrounding this distant world. Surprising magnetic field interactions have been detected around Pluto, challenging previous assumptions about the planet's magnetic properties. The origin and nature of these anomalous magnetic fields present a scientific enigma and raise questions about the planet's internal structure. Pluto's formation in the Kuiper Belt, a region beyond Neptune filled with icy bodies, remains a puzzle for astronomers. In 2006, the International Astronomical Union, IAU, reclassified Pluto as a dwarf planet, a decision that sparked debates and discussions within the scientific community and among the general public. The reclassification was based on updated definitions of what constitutes a planet, and Pluto's orbit and size placed it in a new category. Since its discovery, Pluto has been the subject of numerous scientific studies and exploration efforts, including the historic New Horizons mission by NASA, which provided unprecedented close-up images and data of this distant world. New Horizons' flyby of Pluto in 2015 transformed our understanding of this dwarf planet, uncovering a diverse landscape of icy mountains, vast plains, and intriguing geological features. The study of Pluto continues to yield new discoveries and insights into the formation and evolution of our solar system. Future missions and research initiatives are expected to further unravel the mysteries of Pluto and its neighboring objects in the Kuiper Belt, shedding light on the dynamic nature of these distant worlds. Don't forget to like, subscribe, and hit the bell for more fascinating cosmic content.